So let's start. When the parabola opens upward, then we have this equation. All right. So the k has been added to p. Again, on the opens right and left, it was h plus p and k. But by this time, we have h, comma, k plus p, right? So the difference is that the p is positive and the p is negative. It opens upward and downward, all right? So parabola with vertex hk, the following characteristics. Again, we have, and by the way, the directrix here is k, it's subtracted by p. Subtracted by p. And the axis of symmetry is x is equal to h. The other one is k on the right and left. Okay? So the parabola with vertex hk, we have this equation. So we'll repeat. We have this is for opens right or left. Here, when the x is squared and it is opens up or down. And the focus here, the h is being added to p. Remember that. And then the k is being added to p on opens upward or downwards. Here, less than 0 opens to the left, greater than 0 opens to the right. Less than 0 opens downward, greater than 0 opens upward. Okay? So the lattice rectum is the length of the opening of the parabola is 4p. The length is 4p. And the endpoints should be this, h plus p, k plus 2p. H plus p and k plus 2p. Right? H plus p and k plus 2p. H plus and minus 2p, k plus. Before it was only h, right? Now we have the h plus p, k plus 2p. Remember this? Axis of symmetry, y equals k, and direction is horizontal, x equals h, direction is vertical. Okay? And we have also directrix formula. Okay? So let us try again the example so that we can be able to repeat and recall. So we have two rules for equation of the parabola here. When we have this right or left, up or down. When p is bigger than 0 and p is less than 0. Okay, y minus k squared equals 4p x minus, here x minus h squared equals 4p y minus k. When the parabola is upward and downward, right or left. Okay, and the general rule is y squared plus dx plus ey plus f equals 0. X squared plus dx plus ey plus f equals 0 respectively. This is right or left, up or down. Example 3, write the equation of the parabola in general form that satisfies the given conditions. Draw the parabola, its focus, and directrix. So let's start on letter A again. This is negative 2 and 3, and then the focus is at negative 4, 3. So let us try to graph first the vertex and the focus. The vertex and the focus. Let us see what is happening to that. Okay. So let's try first the negative 2, 3. The negative 2 and positive 3. And then the focus, that's the vertex. And then the focus is at negative 4 and 3. All right. So this is the focus and this is the vertex. Negative 4, 3, and negative 2, 3. As you can see that the focus is on the left side of the vertex. So, means to say that the parabola opens going to the left, right? Because it can't be going to the right because the vertex is over on the left side. The focus is on the left side of the vertex. So it is understood that we have the parabola opens to the left. But we don't know the lattice rectum endpoints. We don't know also the value of our P. So we cannot be able to write our equation. So let us have our equation first for the parabola that is opens to the left. Okay, so I give the parabola that opens to the left. It's y minus k squared is equal to 4p x minus h. This. So we have the h and k, right? Do we have the h? The h is at the vertex, and then the k. So h is negative 2 and 3 here. And that's the h. And then the 3 is the k, right? So let us write h is negative 2. And also we have k is equal to 3. Okay? So let's go back to our formula opens to the left. Okay? So we have it here. This is left and right. Okay? So since we have our h already, so therefore we can be able to get our p, our x, and our y. Okay, is it possible to get the value? So since the vertex and focus both on the axis of symmetry and their coordinates are the same, the axis of symmetry is on the line y equals the axis of symmetry. Axis of symmetry. Again, let's recall our axis of symmetry. Where is it located? This is our axis of symmetry. Okay, it's over here. And then here is the axis of symmetry. So when it is horizontal, when it's vertical, and we can have our value on the line. So what is the formula of the axis of symmetry? It's on the line what? Y is equal, y minus 3 is equal to 0. Excuse me. So y minus 3. So therefore, y is equal to 3. Okay. The focus is located on the left of the vertex. Therefore, the parabola opens to the left. The vertex is at negative 3. Suggest that h is negative 2. So the focus is at negative 4, 3. So the focus is at negative 4, 3. So what is the formula for our focus? The focus is as h plus p, right? So h plus p. But what is the value of the first? H plus p is equal to negative 4. So therefore, we have the h value. What's the h value? It was negative 2. So we'll substitute negative 2 plus p equals negative 4. So p equals negative 4 plus 2. So what is the value of our p now? P is negative 2. Isn't it that p is less than 0, then the parabola opens to the left. Okay? So we have now our p value, we have our h, and we have k. We can substitute now to our formula of the equation. So let us substitute now. Where is the p value? Doesn't want to move. Anyway, let us write. Okay. here now. Why you don't want to move? Okay, so this is our x minus y minus k squared equals 4p x minus h squared. So we have our center at hk. What was it? It's collapsing. So what was our focus? Do you remember the focus? It was at where? Negative 3. That was negative 3.
Negative 4 and negative 3 po.
Negative 4 and negative 3. That is our focus. What about our vertex? Negative 3 and 2.
Negative 2 and 3 po.
Negative 2 and 3. Negative 2 and 3. Okay, so this is our H and this is our K. So what was the P
Sir,
that we got?
sir, sa focus po, it's 3. Negative 4, tapos 3 po.
Okay, yeah. All right. What is happening to my board? And our p-value, it was negative 2, right? So let us substitute now to our formula, right? So we have y minus k, the k is 3. So y minus 3 squared, that's 3. My cat is noisy. Can you hear her? So k minus 3 is equal to 4 times the p, which is negative 2, and x minus h, it was, this is the h, so plus 2. Right? So let us solve y minus 3 squared equals negative 8 x plus 2. Okay? So then we will be getting the value of the general form, and it doesn't want to move. What happened to the hand? The hand. Wait, I need to close it first, probably. Yes, I want to change. I need to close the, doesn't want to close. And I'll pause for the, okay. So K is 3. So Y, the K is 3. So we will put 3 here. Y minus 3 squared is equal to 4 times the P, which is negative 2. So times negative 2, x minus h. So the h is plus 2 squared. So then we can expand this since we are going to the general form. So we will square the binomial y squared minus 6y plus 9 is equal to negative 8 x squared plus 4x plus 4. Then we combine like terms, we remove the parentheses. So y squared minus 6y plus 9 equals negative 8x squared minus 32x minus 32. We just transpose, we just distribute negative 8 to the trinomial. Why we have 2 squared? We just only have 1. it should be only this. I'll repeat. I'll erase that because we are on the red. There is no squared. Okay? There is no squared. So this is negative 8 x plus 2. And then we have negative 8x minus 16. Then we will combine like terms. So we have y squared minus 6y, or it can be plus 8x minus 6y plus 9 plus 16 equals 0. Okay, then we can have y squared plus 8x minus 6y plus 25. So this is the standard form of the parabola. Okay, so make sure that you have only 1 to the power of 2. Okay, the y squared. So when the parabola opens right or left, it is y squared. All right, so let's go to the next one, which we have. Okay, the standard form is in the y form. X, okay. It's always x. Because here they put y on the value. Okay, so that is the parabola. Now, what about how to graph the parabola? So since they did not appear the lattice rectum, the end of the, let us erase this first. Because we cannot know the endpoints of the lattice rectum until we can get the formulas of the lattice rectum. So what's the formula of the endpoints of the lattice rectum? So h plus p and k plus 2p. Okay. H plus p and k plus and minus 2p. So this is the length of the lattice rectum. Length, please write this one because they did not indicate this in the book. Length of the lattice rectum. So this the endpoints. Okay. So what is our h? The h given is negative 2. And our p is also negative 2. And then k is 3 plus and minus 2 times negative 2. Right? So we have negative 4 and 3 plus negative 2. At the same time, negative 4 and 3 minus negative 2. So then we have the value of the endpoints would be what? Negative 4 and 1, also negative 4 and 5. So let us graph which is negative 4 and 1. Negative 4 and 1 is here. Negative 4, 5 is here. Now we can graph our parabola. So this is the vertex. And also there. Okay. So this is the axis of symmetry. Or the directrix. Directrix is same with opposite of that. Okay. So which is 0. Y is equal to 0. Okay. Now let's go to the next one. We have the next example was The vertex is at 3, -5, and the directrix is at y plus 8. Vertex 3, -5 here. The vertex. So vertex 3, -5. And then the directrix has y plus 8 equals 0. That's the given. Okay. So what are we going to do here? We have to solve. So the vertex is at, again, HK, right? Okay. So let us now graph where is the vertex. 3, -5, you will see first. 3, -5 is over here on the fourth quadrant. This is 3, -5. But the directrix is at opposite of the focus, and it is at y plus 8. So it is at -8. So here, y equals -8. So where is -8? It's over here. So when the directrix is over here, so definitely the parabola opens upward. So you are expecting that the P is positive, right? So P, we have the formula of the P is equal to K, and which is minus the value of our directrix. Okay, so which is the y. So therefore we have P is equal to what? P is -5 minus 8. So P is equal to -5 plus 8. So P is -3. So since the focus, positive 3, sorry. Since the focus is positive, the P is positive, then it is opens to the right, upward. So therefore, the coordinates of the focus are, what are the formulas of our focus? So let us go back to our formulas here. It is opens to the right. The focus, it's at H and K plus P, right? So the focus is H and K plus P. So let's go with the focus H and K plus P. What's the value of the H that we got? It's 3. So 3. And the K, what would be the K? It's -5 plus 3. The P is 3. So therefore, the focus is at 3 and -2. So can we graph now P and -3 and -2? It's there. 3 and -2. So it's open, it opens to the right. Now, what about our lattice rectum's endpoints? So we have the formula that what we got here, H plus 2P and K plus P. H plus and minus 2P and K plus P. So these are the endpoints of the lattice rectum. Okay. So the endpoints of our lattice rectum, H plus minus 2P and K plus P. So we have the H. Again, we have the H. Oops, it's not there. H plus 2P, K plus P. Right. So what is the H that we got? 3. Plus and minus 2 times the P, which is 3. And the K, it was -5 plus 3. So here we have, if it is plus 3 plus 6 is 9 and -2. And then the other one, 3 minus 6 is -3 and -2. So let us try 9, -2. So 9, negative 2 is over here. 9, negative 2 is over here. And the other one was negative 3, negative 2. So negative 3, negative 2 is here. Okay? So this is the endpoints of our lattice rectum. Okay? So now we can be able to write the formula. And can you hear my cat? And we have our, where is the birthday celebrant? She's not here yet. Red. Okay, so what is our formula? Red is here?
Yes po. She's in a conference.
Okay, so what is the formula of our opens upward? So it should be what? X minus H. So X minus H squared plus 4P equals 4P equals 4P and Y minus or plus minus K, right? So therefore we have X minus H, the H is 3, equals 4P, which is also 3, and Y minus K, which is 5, negative 5, so it's now 5. Then we will expand. So x squared minus 6x plus 9 equals 12 and y plus 5. So we have x squared minus 6x plus 9 equals 12y plus 60. Then we will have x squared minus 6x minus 12y plus 9 plus 6 minus 60 equals 0. Then we will solve x squared minus 6 combined like terms minus 51. So this is the equation that what we get. It's the same thing here, right? This one, x squared minus 6x. Okay, so you should know the P, the H, the lattice rectum endpoints, and etc. Okay, now let's go to now letter C. Letter C, since the axis of symmetry is vertical, the equation of the parabola is in the form of this. So what are the given, by the way, on letter C? Letter C, the parabola passes through the point negative 1, 5 and its vertex is at 1, 1. Passes through the point negative 1, 5 and vertical axis is just 1, 1. Okay. So we have passes through negative 1, 5 and its vertex at 1, 1. So vertex 1, 1. So it is H and K, right? And then the parabola passes through the point negative 1, 5. So we have X and Y. So it's just a simple substitution from our formula. Since the axis of symmetry is vertical, then the parabola is open to the value. Since the axis of symmetry is vertical, so the equation of the parabola is in the form of this. So therefore, it opens upward. So it will become x minus h squared equals 4p y minus k. So let's see if it is upward or downward. We don't know the value of the p yet. So we have the x. X is negative 1. H is 1 minus 1 squared equals 4p. We are looking for the p. And y is 5 minus k, which is 1. So negative 2 squared equals 4p times 4. So therefore, we have the value 4 equals 16p. So let's get the p by dividing both sides by 16. Cancel out. So p is 1 over 4. Right? So that's our p. So therefore, our general form is x minus h squared equals 4py minus k. So x minus h, the h value is 1. 4 times p is 1/4, y minus k, which is 1. So therefore, we will expand this. X squared minus 2x plus 1 equals cancel the 4. So y minus 1. Then after that, we have x squared minus 2x minus y plus 1 plus 1 equals 0. So x squared minus 2x minus y plus 2 equals 0. Okay? So if you will graph that, that's the value. And you know the lattice rectum endpoints. Okay? So let us try to have these equations. Let's go back here. Now, what about if you are going to express each equation of the parabola in standard form? Let's try number 1. This. So let us reverse this is what we got on the first, right? So let us reverse this by completing the square. So we have y squared minus 12y equals 4x minus 28. Okay? So by this time, we can be able to uh, combine like terms. And we have the formula of the equation. So let us try to combine like factorize now. So by completing the square, we will get this, the b, right? What's the value of the b? It's 12. We will divide by 2, then square. So 12 divided by 2 is 6. And square it, we have 36. So once again, we went back to our completing square. We add 36 here. We also add 36 there. So therefore, we have y squared minus 12y plus 36 is equal to 4x. Negative 28 plus 36 will give you what? 8, right? So plus 8. Then we will factorize this, the perfect square trinomial. It is y minus 6 squared equals 4x plus 2. Look, we are now on the standard form, right? We can now get the value of our h and k. So since we have this, we can be able to get our h and our k. So if we have, you remember, if the p is bigger than 0, then the parabola opens to the right. And then the h and k are given. So this is our h, and this is our k. So h is 6, and the k is negative 2. Right? And our p is 4p is equal to 4. So divided by 4, so our p is equal to 1. Okay? So now let us graph this. So negative 2. Let's go back to that. Y minus k. So this should be k. And these are reversed. K and h, right? Y minus k. When it is horizontal, y minus k squared equals 4p x minus 2 squared, minus k h squared. That should be h. right? So therefore, we can be able to get our h, which is not this one. This should be our k, and this should be our h. So the k is, the value of the h is -2, and the k is 6, and the p is 1, right? So now we can get our lattice rectum. What's the formula of our lattice rectum? What they call Ali, what's the lattice rectum endpoints formula? So can we revise our lattice rectum formula, which is the equation is on the value of the right side. So the lattice rectum formula is h plus p and k plus 2p. Okay, h plus p and k plus 2p. H plus p, k plus 2p. All right. So what is our h given? The h is -2, -2 plus 1, and also k is, what's our k? 6 plus and minus 2p. So -1 and 8. And at the same time, we have -1 and 6 minus 2, 4. So we can graph now our parabola. So let us try to insert the media. Okay. So let's start with the vertex. What is our vertex? -2, 6. -2 and 6. And also, we have our endpoints. We don't have the focus yet, so -1 and 8. And -1 and 4. Is that correct? Up and to the right. And definitely our focus is here, which is the value of -1. So this our focus is at -1, 6. So we just add to the right of h. So h plus p and k. Right? We add p to the h. Okay, let's try again letter B or number 2. What's the given a number 2? It is x squared. So what do you expect to our parabola if it is x squared? It opens either upward or downward. So let us do letter B. Letter B is x squared minus 2x minus 4y plus 13 equals 0. So let us combine like terms and we will complete the square. Right? So, is it already time? Okay, just wait. I have here x squared minus 2x is equal to 4y minus 13, right? So let us get the value of b. The b is -2 and divide by 2, square it is equal to 1. So we will add 1 left and right. Plus 1 here, plus 1 there. So it will become x squared minus 2x plus 1 is equal to 4y minus negative 12. Correct? So therefore, we will complete the square. X minus 1 squared is equal to 4 open bracket y minus 3. Okay? So if the parabola opens to the right or to upward or downward when p is positive. So we have the value of the p. So 4p is equal to 4 divided by 4. Then the value of p is 1. So 1 is positive. So the parabola opens upward. Okay? So you know what to do when it is opens upward. So we have the rule that what we got there. And we have our equation of the parabola opens upward, right? So when we have that, we can get our rule if x, so x minus the value of the h now squared equals 4p y minus k, right? So let's go back to our rule of the parabola. So what we need there, we need our focus formula, and we need to get our, okay, so x minus h equals 4py minus k. So our focus is hk plus p. And the lattice rectum is what? H plus 2pk plus p. H plus 2pk plus p. All right, so h plus 2p and k plus p. Okay, so let us get our h. Our h is 1. That's the vertex. And the k is at 3. So we will have h will be 1 plus 2 times p, which is 1. We got the p here. And k plus p, the k is 3, the p is 1. So this plus and minus. So 3 and 4. And at the same time, we have 1 minus 2 is negative 1 and 4. So let us graph now our parabola. So insert. Okay, where is the vertex now? It's HK, right? HK 1, 3. 1 and 3. Oops. V1, 3. And our lattice rectum endpoints 3, 4. 3, 4. So over here. And we have negative 1, 4. Negative 1, 4. And the focus, it's here. Okay, so this is our focus is at 1, 4. This is negative 1, 4. And this is definitely our directrix. Okay,